you need to put the Mysql on. I'll show you. This is. Yeah, do you have the Mysql there? Yeah, please put it in.
That one?
Yep.
Okay. So I put it on my neck.
Yeah, click that onto the top there. Just like that.
Ah, okay, thanks.
Click it onto your...
Okay, so is it working?
Just...
Is it working?
Yeah.
Okay, thanks. So, may I start? Okay, hi guys. My name is Tamás Bunt, and I was working with on LibreOffice for 3 years from now, and now I am a contractor at Collabora Productivity. The main topic I would like to talk about is LibreOffice Base. Maybe it's not as a famous component of LibreOffice as Writer and Calc, but it's used in different areas. First, I would like to tell us some things about Base. So if you are not familiar with the component, I would like to let you know some details. There are two modules which are strongly related to the Base module, the connectivity and the DB access. The connectivity module is used for connecting to a database management system. Microsoft Access uses its own database management system, but LibreOffice Base is used used only with external databases. At least it's not not in the core project. Also, there is a module called DB Access. It is representing the logic which is used for showing the UI itself and operating the database management system in the background. And what I would like to talk about is the improvements in that area. There are three main topics which I would like to talk about. The first one is the default embedded database management system. There are two options when you want to connect to a database. You can either have a external connection, that means that you can use a server, a database server, or you can use an embedded database. That means that when you have the ODB file, it's actually a zip file, as you may already know. And in the zip file itself, there is the data and the schema of the database. If you want to go for an embedded database, then you can choose either Firebird or HSQLDB. That's one topic, because we wanted to make Firebird the default, and HSQLDB is obsolete. Other topic is the migration from HSQLDB to Firebird. That's needed because we turned HSQLDB as an obsolete solution, and it has a Java runtime environment as its dependency, which is a huge dependency in its own. And also, the third topic is about MySQL connector. With LibreOffice, you can connect to MySQL and MariaDB not only with the JDBC, but with the native connector as well. And First, I would like to talk about the connectivity module and the SDBC driver itself. It's the API which LibreOffice uses, and it's very similar to the GDBC API. We have a driver which can create connections, and with each connection we can create statements. For example, a query or an insert statement, and so on. And we can have, for example, with that X database metadata information about the database, and all that can be received with the help of a result set. And it also has information which is contained by X result set metadata. So these are interfaces, and there are several implementations of the driver for each database management system or for each connecting solution. For example, we have ODBC and EDBC, which Access has as well. But LibreOffice has plenty of native connectors. These are just examples. The three interesting example is the HSQLDB and the Firebird driver, which I'm most concerned in, and the MySQL, that's the native connector, name of the implementation of the native connector. And with HSQLDB and Firebird, we can choose either to connect to a remote server or to an embedded server. Okay, so comparing Firebird and HSQLDB as an embedded database, I found three reasons why we would go for Firebird. The most important is maintainability, because HSQLDB is Java-based database management system. Because of that, we have to make Java calls from C++, and that causes some trouble when we would like to debug the application. And also another aspect is performance. And the third is the state of the implementation itself. That's the one we can change. So one of my works lately was about improving the Firebird driver. Like 2 years ago, we made an upgrade to the 3.0 version, which was kind of a huge work because the architecture of the Firebird management system, database management system changed, and because of that, we had to remake the make files related to this, which can be a bit tricky. Also, another improvement was to allow auto-incremental values and saving the archive format of Firebird inside the ODB file. With this method, we achieved that the ODB file is portable, which is kind of a requirement we have. Also, creating relationships didn't work with the UI, which is now working, and there are a lot of more changes which had less impact, but they were interesting as well. Okay, after upgrading the Firebird driver, there is this need that we should get rid of the HSQLDB because of the Java dependency. That's a tricky thing to do because one thing that is really needed from the users is to ensure that their files are usable in the future times as well. So backward compatibility is really important. Because of that, we created a migration assistant tool which has the task to move the database itself, which is inside the ODB file, to another format. the Firebird format. Problems that I faced during the migration, the creation of the migration tool, is that the migration should be processed without the HSQLDB system itself. So that uses Java environment, and because of that it cannot be used. And that's the whole point of the migration. So I had to look at the implementation of HSQLDB and also the file format, which was not documented in every pieces of it. Also a big challenge was to understand the binary format in which the data is stored. Okay, but the migration assistant tool is created, and it works in almost every database that it's created. Of course, there are problems which are tracked in the Bugzilla. One big problem is that we also want to migrate the views, and the views can be really complex, considering that we have functions which are not compatible and which are not present in the SQL standards. For example, when we want to migrate HSQLDB to Firebird, HSQLDB has the concat function as a keyword for concatenating strings. On the other hand, Firebird has these two vertical lines to do that. And that's just one example. There are a lot of functions which are not in the standard. And also another need is to that would be good if this tool would be able not only to migrate HSQLDB to Firebird, but to migrate HSQLDB to everything. That means the SDBC API, or to move a step further, it should be possible to move something to something. Of course, it has a complexity. And I would like to now turn to the third topic, which is the MySQL connector. So what we have here, there are more ways to connect to a MySQL or MariaDB database. One is JDBC, and there are three native ways. There are the C API and the C++ API, and the C API is implemented by MariaDB and MySQL part. And the interesting difference is the license. While MySQL, the C++ connector, cannot be used in the core project because it's GPL licensed. But on the other hand, MySQL, the MariaDB C API could be used. And because of that, before the work we did, the MySQL native connector was used as an extension. Okay, so what? The problem with having the MySQL connector as an extension is that it needs further steps to install it. It seems to be not a big problem, but it annoys the user, and the user has to know that it exists, and so on. But the biggest problem with that is maintainability, because when it is an extension, the driver itself, then it wouldn't track the changes which we made on the core project, and because of that, it can happen that the extension cannot be used anymore. Also, for example, Clang plugins wouldn't apply on the extension, and any other static analysis tool and test and so on. Okay. When I implemented the driver, I used the new driver. I used the MariaDB C API, and in that way we could move the whole stuff into the core project. And there is an example function just for fun, so you can see that it's a C API. This function, MySQL statement prepare, is used for preparing a prepare statement. It gets 3 parameters, a statement handle, which represents the statement itself, and the SQL query. Okay, and what I also have here is interesting concepts of the MySQL implementation. One interesting thing, at least for me, was the memory management, because I get a bunch of pointers from the MySQL API, but I don't have to free them. There are separate functions for freeing the resources. Also, an interesting thing for me, was that there are 2 implementations for result set and result set in the C API. Separate implementation for the statements and the prepared statements. That's interesting because SDBC has only one typically, but that could be solved. And another interesting concept is how to move the cursor. MySQL allows only to move the cursor of the result set forward, but SDBC would allow to move it backward as well. That can be done, but it's a performance problem, because then you have to reopen the cursor, and then you can go wherever you want. Okay. Another thing that we accomplished is to test the functionality of the driver. The problem here is that it's not an embedded database, so we cannot do that automatically. The one who wants to test this functionality has to have a server, MySQL server somewhere. And because of that, the unit tests which we made it can be used only with explicitly saying it after the build. So there is this manual execution, and we can pass an environment variable which contains the URL for the database and the password, and then the functionality can be tested. Okay, and some other interesting problems I faced. One is parallel execution of more result sets. It's not supported by the C API, but supported by the SDBC. So what I did is to store the result in memory, and with that it can be queried later from separate, and that way I can free the MySQL resource, and I can use it again. Okay. Another challenge was the X database metadata implementation, because the C++ API, which was before, had provided methods which was really similar to the SDBC methods, so there were nothing to do. But with the C API, these methods are not available, so I had to use SQL queries. The challenge with that is that it's not as strongly typed as C++, and the developing in that way is a bit tricky. But most of the methods now works. Okay, and the third, which I would like to mention, is that 3 days from now, I worked on a bug here in Brussels in the Hackfest, and that's when we use the native MySQL API, so the SDBC API which I implemented. Then when we open the Relations tab, this tab is used for creating relations, which means foreign keys mostly. So when we open it, it turns out to be a bit slow. That means on my machine with my MySQL server, it takes about 7 seconds. And why is that so slow? One answer could be that also a bunch of system tables are shown in the tables menu there, and that is maybe not so interesting, because most of the users is not concerned about the relations between system tables. So my plan is to get rid of those system tables and only query the normal tables for the relationships menu. Okay, so that was all I wanted to talk about. I don't know if you have any questions. Yes?
Testing database backends. I arrived late.
Yeah, so I don't know when did you come?
Too late, obviously.
Too late, obviously. Okay, yes?
Do you track the Bacilla reports about migration?
Yeah, about the migration.
There are a lot of reports about what not works. Do you track this?
Yeah, about the migration part, there is a tracker page in Bugzilla which contains links to all of those issues. There are a lot which are solved, and there are a lot which need further work on that. Yeah, I'm aware of them. Okay, thank you.